Scenario. The diagram below shows a meter stick which is balanced at the 5 centimeter mark. A 5 kilogram mass is hanging at the 30 centimeter mark. Question. Determine the torque and the direction of rotation for the meter stick. The answer. You're going to use the torque equation, radius perpendicular times force. And the force here is going to be the force of gravity that is on the FG on the 5 kilogram object. So we plug in the values because again, force of gravity is mass times gravity, which is 10 in this case. I just rounded up. Here you should get the value of the torque is 100 Newton meter. And notice it is going this way, so it's going to rotate this way, which is going to be counterclockwise. And then the next question asks, at which label position must this 10 kilogram object here be hung so that the meter stick is in equilibrium? Well, we can already knock off the answer because if we put the 10 kilograms on the A side, it's just going to help the 5 kilogram object. So there's no way it's going to be in equilibrium. It has to be placed on the B, C, or D side so that it does balance. That's the reason why you could knock off A. Let's take a look at the calculation here. We know that the torque supplied on the left-hand side was 100 Newton meter counterclockwise. So we need a equal and opposite, which is going to be 100 Newton meter that is going clockwise to balance that out. So that 10 kilogram block has to be placed so that it supplies 100 Newton meter clockwise torque. That's the equation for torque. We plug it in. So the torque that it needs to be equal to is 100. We know that the force of gravity on the 10 kilogram object here is going to be its mass, which is 10 times gravity, which is going to be 10 here. That leaves you with 100 here. If you divide 100 to both sides, you get 1 meter is equal to the radius. But notice this problem is in centimeters, so you have to convert it into centimeters. So what does this mean is that the radius has to be 10 centimeters away from the pivot point or from the x equals to 0. So this is basically when x is equal to 0. Okay, 10 centimeters away would be, there you go, at position B. So position B is where the 10 kilograms should be hung to keep the meter stick in equilibrium. The reason why the mass can be placed closer to the pivot point is because it has a higher mass. That's why the R is a lower value than the 5 kilogram object.